All right, here is a situation where we have a garden on a river, and we want to find out what the greatest possible area is. So we got a gardener, has 480 feet of fencing to fence a rectangular garden. It's a rectangle. And we know that one side of the garden is bordered by a river. That's important. So we got this situation here. Here's our garden, and we're just going to put fencing on these three sides. We want to know the dimensions that would guarantee the greatest possible area. All right, so we need to write an equation for the area, and then we'll need to find the maximum area. So we know that, we got to start fencing this garden somehow. So let's call this W. You could call it X if you wanted also. So we got a width. That means that this is W also. So we're going to put some fencing there. All right, so we've used W feet of fencing here, W feet of fencing there. How much fencing do I have altogether? I have 480 feet. So how much do we have left for this third one here? Well, we have 480 minus 2 W's. All right. Now, we want to find the area. Well, how do I find the area if I don't know the widths and the lengths? Well, that's the whole idea, is we don't know them, but we can still use algebra. Algebra says area is length times width. So the length is this guy right here, 480 minus 2w. That's our expression. Put in parentheses, that's our length times the width. And if we distribute this out, we get the area is 480w minus 2w squared. All right. And if you want, you can put that into standard form. Just take the negative with the 2 there. And we see that it's a quadratic function. If you were to graph this quadratic function, you would get a parabola. And that parabola will have a maximum height. The maximum height happens at the vertex. All right. So how do we find that vertex? Well, we find it at using the formula x equals negative b over 2a. That's where our axis of symmetry is, and the axis of symmetry goes through the vertex. So in this case, instead of x, we have w. W equals negative b over 2a, so we're going to go with negative 480 over 2 times a, which is negative 2. And that's negative 480 over negative 4, which is 120 positive. So that means when our variable w is 120 feet, we're going to get a maximum of area. See, area is our function here, and w is our independent variable. All right, so the question now is, what is the area? So this is w. All right, so the width, the shorter side will be w. What's the longer side going to be? Well, the length, the longer side, is 480 minus 2w, which is 480 minus 2 times 120, which is 480 minus 240, which is 240. So this is, oh, why did I put a w there? This is 120 feet. This is 240 feet. So the area will be 120 times 240 feet. And probably should be able to do that. 12 times 24 would be 24 plus 48. You know what? I better do this. I'm going to make a mistake on video, and yeah, then we'll have a video that's wrong. So 120 times 240. And what do we get there? We get 2880. It's exactly what I was thinking, right? Okay, 2880. 800, I should say. So 28,800 feet there, right? So the area, 28,800 square feet, right? That's in square feet. All right, so that's how we solve that. So again, the idea is we're looking to get a quadratic equation, because quadratic equations make parabolas, and parabolas have maximum values if they're upside down or minimum values if they're right side up.